Welcome to this tutorial in which we are going to do a summary of loci and basic constructions. So before we begin, I would urge you to have your construction equipment so that anything that we touch on, you may be able to make a quick follow-up. Let's have a quick word of prayer. Father, Lord in heaven, we invite you this session that you may be able to teach us, you being the greatest mathematician we've ever known, able to bring these mathematical concepts into our fingertips, that we're able to understand them and grasp them as we prepare for eternity and this life here. Just may pray. Amen. So I believe you have your basic items. If not, feel free to pause the video so that you may get them. Now I'll also have mine, but basically let's just make an overview of basic geometrical constructions and loci, so that you may be able to know what is required of you. Number one, you should also review basic geometric constructions, that's construction by using ruler and pair of compasses only. You should also know the definitions of locus and situations. You should also, number three, know the types of loci, that's locus of a point equidistant from a fixed point. I'll also go overview that. We'll also look at locus of a point equidistant from two fixed points. We'll also look at locus of a point equidistant from a given line L. I believe you can see them from the screen, so if I'm going too fast, you'll just pause because I need to cover up much in a very short time. We'll also, number four, look at locus of points equidistant from two intersecting lines. Then the last three, constant angle loci. Also look at loci of inequalities and intersecting loci. So here we have a quick question. Please pause the video and be able to look at it. I'll not be able to read it through, but pause the video if you have any questions in what you will not be able to see. Please send a message that I'm able to get it and we'll be able to sort it out. So quickly about locus. Locus, basically, I believe the previous tutorial we said, locus is the displacement of a specific point, or simply a point that is in a particular motion. So a locus of a point is defined as the movement of that point under given conditions or restrictions. So for example, if it's fixed to a particular point or equidistant to a specific point, those are the various conditions that we should be met when looking at locus or loci in plural. If point A is a fixed point and point B moves in such a way that it's 4 centimeters from point A, which is the fixed point, and point B is the point that is moving, then the locus of point B is simply the circumference of a circle. We can be able to note that from here. So if A is the fixed point and we are moving point B around that particular circle, then point B is the locus, and what it will trace as the locus of points is simply a circle. So basically after that, we have still looked at point B and point A. A locus can be moved, can be the movement of a point under given conditions that it creates an arc, line segment, or a circle. That's basically what we have looked at as that example. So if a line, I would like you to be reading it with me here. If a line or arc moves, it creates an area. I believe now you can notice here, if for example you have a point here and that point is fixed to another point, whereby we said, like for example, you have A there and B here, and B is moving in such a way that it is creating a circle. Notice that because point A is fixed, it's moving as a line, creating an area. Or you can also have another line AB here, moving in such a way that the full line is moving at the same time. So notice, from the point of origin to the new point it will reach, you'll find that it will have drawn a rectangle, which is the area that we're speaking about. So when a plane figure moves, it creates volume under given conditions. Now let us check. We have looked at how it creates an area. Now what about volume? If now a plane moves, we'll be able to have a volume created. Now let us get to types of loci. We have basic several number of types of loci. Last time we looked at 4, but now we are going to try to expand more with various examples. Now the first one is loci of a point equidistant from a fixed point. So given a point A, d centimeters, from a fixed point B is the circumference of a circle, center B, radius d centimeters. So for example, if I have my fixed point being B, and A is the locus of point that is fixed to B, and it's equidistant in such a way that it is d centimeters from the center or from the fixed point, it will create a circle with the radius d centimeters, or basically circumference. Number 2, locus of our point equidistance from two fixed points. So for example, if I have two fixed points, whereby my fixed points are A and B, I can be having, for example, a locus from P1 to A, which will be equal to P1 to B, or P2 to A, P2 to B, like that. So it's basically a specific locus that's moving along this line, a locus P, but at various points. So you'll notice that there are various conditions. It is fixed, it is equidistant from these 2 points, meaning it is perpendicular. I believe we spoke about that in the previous tutorial. So various things that you need to know. In the first one, we said it's a circumference, meaning it's a constant distance locus. And in the second case, it's a perpendicular bisector locus. The third case, we have a locus of a point equidistant from a given line L. So if you have a line L and it's equidistant, locus of a point equidistance from a given line L, you'll have another parallel line in a nutshell, because there are several number of points, meaning that is what you'll have. I believe you can be noting the various things. If you have questions, you just pause them so that you're able to work over them. Number 4 is locus of points equidistance from two intersecting lines. If I have two intersecting lines, AC and AD, and I have a line in between them, it is simply an angle bisector locus. So that's what we have if I have a line equidistance from two intersecting lines. Now from here, we didn't cover them in the previous tutorial, but we shall be able to add them here. We have constant angle loci. In this case, if P is a locus of points such that APB, angle APB is 60 degrees, and AB is a line segment 6 centimeters. So notice we have P is a locus, and it's being restricted in the movement of saying angles and a triangle. So if P is a locus of points such that angle APB is 60 degrees and AB is a segment of 6 centimeters. So what does it mean? I'll have my segment here of 6 centimeters and then construct angle 60 degrees at point P here. I'll ensure that this is 60 degrees. Now, how will you be able to get that at 60 degrees? So basically what you'll do is simply to construct an equilateral triangle. And you know how to construct an equilateral triangle. You'll basically have its bases at 60 degrees. You know how to construct a 60 degrees angle. I believe I showed you in the previous tutorial video. Though we'll be able to try to cover it in the next tutorial, in which we are going to be looking at very basic constructions. Here we are looking at summaries. So after constructing my equilateral triangle, I'll then draw an inscribed circle, which will touch the specific vertices, and you'll notice that any triangle that you'll draw to that particular circumference, it will be 60 degrees. So it will mean that the locus of P is 60 degrees from this line segment that you have been given. That's the basic condition that we have. So another question that I would have for you is this one, about drawing line PQ 7.5 centimeters, construct that and that and that. So there will be quite a number of questions, but please try to bear with them so that you're able to be well acquainted with constructions. Now from here, I'll quickly go to the fifth, I believe it's the fifth, not the sixth loci, which is loci of inequalities. Loci of inequalities, this is constructed by shading the unwanted or the wanted or unwanted region. For example, if my condition is that I have a loci P and AP is greater than PB, I'll draw my loci in such a way that I know what I need is the part PB, from P to B, because that's all the region that is wanted. No, I'm reading a different thing. This is a different statement. The statement is just down here. So basically, I'll have such a thing. This is just a diagrammatical representation, but I'll explain it from the one that I'll have as an example. So for example, if I have my drawing in this manner, so what does this simply mean? What I need is the region from P to B. Okay? Yeah. So I've just confirmed that this statement is just true because I need the region from this. So my answer lies from P towards B because the answer is greater than this particular region remaining here. So try working out this example in which draw a line AB such that that and that and that. So please pause the video so that we may be able to get the question in full and try working out on it. So to make you quite acquainted with the inequalities, it simply means the area is shaded is from P to B. It means AP to PB. This simply means you need the region from P to B. Just to give you an overview of what this simply means. For example, if you meet statement 2, it says, draw the locus of part P such that AP is greater or equal to PB. So greater or equal to PB, that means I'll have a continuous line at P and I'll shade my wanted region here like that, the unwanted region. And then the wanted region will be the one that is continuing from that specific point. And then next, you have been told in the third statement, in the second statement, you draw locus of point S such that AS is less or equal to 4.5 centimeters. So it must be less. You need the region lower than that. I believe you see the sense. If you need the region greater than that, you'll shade whatever is lower. You get the sense? I believe you do get it. So in this case, for example, I need the region greater than AP, greater than this side, so I'll shade whatever I don't want. And if it is greater than only, it's a dotted line. If it is greater or equal to, less or equal to, it's a continuous line. So that's what we have. And basically, up to that point, we will have completed the summary on loci. So please work on the various two questions that I've given you. And I believe you have seen the answers that you need to get. And the other one, you'll get such an answer. I believe I can reduce this. You can see what the answer that you need to expect from you. But do not force it to be that way. If you find something wrong, please raise it up. Because these I'm using the notes that I used in high school. So you can be able to work on those. This is the first question. And I believe you can note the orders. God bless you.